Objective number 2, power rule. We want to take the first derivative of x to the n power. So let's consider the function f of x equal to x to the n power. If n equal to 1, we got the function f of x equal to x is a linear equation. So the graph of f of x equal to x is like this. The tangent line to this function is the same as the graph of this function. So it will be like this also. And the first derivative is the slope of the tangent line. So the slope of the tangent line is m equal to 1. Now if n equal to 2, we got f of x equal to x squared. In exercise 19 and exercise 20, we know that the first derivative of x squared is 2x. And the first derivative of x cubed is 3x squared. Now, what if we want to take the first derivative of x to the fourth power? We use the definition of the f prime of x is equal to the limit of f plus the limit of the function f of x plus h minus f of x divided by h when h go to 0. And then we plug in x plus h into the function and also x into the function. Then we use binomial theorem to expand this. For x plus h to the fourth, we learn in pre-calculus class. And then we cancel out the like terms. So we have 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth left on the top, divide h in the bottom. So we recognize that the h is the common factor. So we factor out the h and then we cancel the h in the bottom. So we're left with this. Now if h approaches to 0, then this go to 0, this go to 0. This go to 0, this go to 0. The first one doesn't go to 0 because we do not have the h left because we cancel the h for when we factor out the h on the top. This is gone, right? So we have only 4x cubed left. 4x cubed left. So the answer is 4x cubed. Okay, so let's look at the logic. So you know that the first derivative of x is 1 when you have x more than 1. So when we have is 2. So if you recognize that 2, 3, and 4, the exponent move down to become the factor in front of the x. The number go down in front of the x. So 2 go down. So that's why we have 2 here, 3 here, and 4 here. Okay, and then the exponent 2, 3, and 4, it decrease 1 unit. So 2 exponent become 1 exponent, 3 exponent become 2, and 4 exponent become 3. So we have the general formula for this is we move the exponent down, so we get n. And then the exponent of the x, the new exponent of the x will be decreased by 1. So n minus 1. So in the book, they prove the theorem. They prove that the first derivative of x to the n equal to n times x to the n minus 1. We're not going to prove this, but we are going to apply this in the problem. So for example, number 1, if we have the function f of x equal to x to the 6, then we want to find the f prime of x, the first derivative. So f prime of x follow the same rule as we have before. We will have 6 x to the 6 prime. We move 6 to the front, and the exponent will decrease 1 unit. So 6 minus 1 is 5. The number 2, the y equal log base 5 of 3. So we take the y prime, which is the first derivative. It's just different notation, but it's just mean the first derivative. This is a constant, right? So we use the constant rule. The derivative of a constant is 0. In problem 3, we take the first derivative of t to the 5. This is the power rule. So we will move 5 to the front, and then the exponent will be decreased by 1 unit. So it will be 4. We want to take the first derivative of r to the 1000 in number 4. We will move 1000 to the front, and then r to the 1000 decrease 1. So that will be 999.